Good afternoon, everybody. In the last lecture, we have seen about the basic concepts underlying chromatographic separations. And we have seen one form of planar chromatography, that is paper chromatography. Okay, so today we'll start with another type of planar chromatography, and that is called as thin layer chromatography. Can you all see my screen?
Yes, sir.
Okay. So here, the small difference is there in the earlier part, that is in the paper chromatography. We have seen that the mobile phase is a liquid, that is a solvent system that we are employing. Okay, and the stationary phase actually was the water molecule which was trapped on the surface of that paper. Okay, so stationary phase was liquid and mobile phase also was a liquid. But here in the case of thin layer chromatography, the situation is slightly different because the stationary phase is a solid material, okay, in a powdered form, which is used to coat the glass or a plastic plate, okay, or a metal foil. Okay, so metal or plastic or glass, they serve as the support material. Okay, and on this support material, we have a very thin uniform coating of the stationary phase, which is in actually a powdered form, but we make a slurry of that. And of course, it has something called as a binding agent. Okay, so binding agent is something which will help that material, that powder, to bind, okay, to bind to the support material. Okay, so sample, like we have seen in the paper chromatography, the sample is applied in the form of a small spot. So for that, we use a capillary tube or a micropipette or a syringe. Okay, and then we place it towards one side or one edge of the plate. And then this plate, the entire plate is kept in the solvent system, right? And then as we have seen earlier, the sample components will be carried by the mobile phase. The plate is kept in the mobile phase. Okay, so mobile phase again is a mixture of different solvents, right? And then these solvents are going to carry the sample spot over the plate. So again, this is a surface phenomenon. The separation is going to happen because the sample molecules are going to interact with the stationary phase and with the mobile phase. Okay, so there is going to be partitioning between the stationary and mobile phase. Different components of that mixture will have different partition coefficient, and based on that, they will get separated. Okay, again, the other thing important here is the number of interactions. If there are more, then the separation will be better. And therefore, I think yesterday I did tell you that if the powder is a very fine powder, okay, with very small particle size, then you have more number of interactions, and therefore the separation efficiency will be better. Okay, I think I have already told you about this. Right, so what are the different materials that can be used as a stationary phase? Okay, the solid could be either aluminum oxide or calcium carbonate, or very commonly we use silica gel. Okay, silica gel in the form of a powder. Then we can also use cellulose hydroxyapatite, that is calcium phosphate. Okay, so all these different materials are there. Different materials are used on the basis of the application. Okay, some materials are adsorbents so that the sample components can actually interact with the stationary phase. Okay, and depending upon the chemical properties, we can select the type of material for a particular application. Okay, so normally in the laboratory, we use silica gel. Now these plates which are used for the support material, okay, they could be of various sizes, but usually we have 5 by 5 centimeter or 20 centimeter by 20 centimeter plates. Okay, of course, this size is not very standard depending upon the number of samples and the type of the solvent chamber that you have. You can maybe change that size also. Okay, but yes, the length of the path over which the separation is going to happen, that is quite important, because if the length is very small, then you cannot expect very good separation. And if the length is longer, if the length is bigger, then of course you can expect more better separation, but then it will also take more time. Okay, so you have two things here. One is the time, and the other is the efficiency of separation. So you have to have the optimum kind of a result, optimum separation. So depending on your experience, depending upon the application,
Not
you
visible.
can not visible. Okay, anyway, I'll start it again. Is it okay now?
Yes, sir.
Yeah.
Yes.
Yeah, there's nothing much to actually see on that slide. Whatever I'm telling you, that is also important. Okay. So the thickness of that layer on the support material could be 100 to 200 micron. So that is a very small particle size material is what we are using. Okay. And then we can use gypsum, that is calcium sulfate, or an organic linker. And that linker or you can say binder is going to allow that powder to bind, or stationary phase to bind on that support material. Okay. And then if you are using another form of TLC, which is called HPTLC, that is high performance TLC. In that case, the particle size is much, much smaller. It is 4 micron to 6 micron size particles that we are using. Okay. So when the particles become more smaller, then you can expect even better resolution or better separation of your sample components, right? Then in case we are using silica gel, then the silanol groups are there on the surface. These silanol groups or the siloxane groups are there. These are what determine the hydrophilic character. Okay, then there are various other materials which are called bonded silica. So if that silanol groups are bound to different kinds of organic chains or organic molecules, like alkyl groups are there, or nitriles, amines, alcoholic groups are there. So if such functional groups are there on the surface of that silanol, okay, then that is called as bonded silica. And with this variety of different functional groups on the surface, we can carry out the separation of different types of material, different type of samples. Okay. Then in some cases, the material which is used for coating, that is the stationary phase, can also have charges. Okay, either we have negatively charged plates or we have positively charged plates, and that also can be used for different types of sample molecules. Suppose you have proteins, and if the proteins are negatively charged or positively charged, then based upon which type of proteins you want to retain on that plate, or how good a separation you want on the plate, depending on that, you can select a particular kind of a plate, either negatively charged or positively charged plate. Okay. So then we can also have modified cellulose support materials. Okay. So in other words, what I want to tell you here is that different types of materials are available for carrying out TLC applications. Okay, then there is one form of TLC which is called adsorption chromatography, and here we can use it for example, we have hydroxyapatite, that is calcium carbonate. Okay, is that correct? Yeah, calcium phosphate, sorry. Okay, so calcium phosphate is called hydroxyapatite. We can use that material as a stationary phase, and that is especially useful when we want to allow the binding of double stranded DNA. Okay, so single stranded DNA doesn't bind, or RNA doesn't bind to the plate, but only double stranded DNA can bind to that plate. And therefore we can carry out, if there are different sized double stranded DNA molecules, okay, then they can be separated on this particular plate. Okay, and the usual mobile phases which are used for DNA separation are hexane, heptane, propanol, butanol, etc. Then sometimes we can also use a liquid as a stationary phase. Just as we have seen in the case of paper chromatography, we have seen that water itself is the stationary phase. So here also we can make use of that. Even water can be allowed to function as the stationary phase in TLC. But usual applications of TLC all make use of solid material as the stationary phase. Okay. Then this is one question which I think I've already given you the answer for this. How do you decide the solvent system? That is the mobile phase. I have told you that different combinations of solvents are used to make the mobile phase. And then I have told you that there are different solvents which have different polarities. Okay, so depending upon what is the type of our sample molecules present in the mixture, okay, we can have either polar molecules or non-polar molecules. We have mixtures of polar and non-polar molecules. Okay, polarity is different for different molecules. And in order to separate such molecules, we employ a solvent system, okay, which has different solvents. Some of them are polar solvents, some are non-polar solvents. We have intermediate type of solvent systems. Okay, the idea is that we adjust the polarity of the solvent system in such a way that the different molecules in the sample will get properly separated. Okay, we should have very good separation between the molecules. Okay, so one way is that either we carry out trial and error experiments. So with the sample, whatever we have, we can use different types of solvents, or we can have different mixtures of solvents, and whichever mixture gives you a better separation, that mixture we are going to use as the mobile phase. That is one thing. And the other thing is that if you have some already have some experience, or maybe from the literature, you can select a particular solvent system which is best for your type of molecules, okay, for your particular sample molecules. Is that right? कळतंय ना सगळ्यांना? हे खूप महत्वाचा पॉइंट आहे. Polarity of the solvent system is adjusted, okay, so that your sample separation will be proper. Okay, because your sample molecules are also either polar or non-polar or intermediate between the two. And based upon the polarity of the sample molecules, you have to decide which solvent system is to be used. Okay, so this is an important point. Then we go to the sample spotting. I have already told you that using a micropipette or a capillary tube, we can apply the sample. The amount of sample is very small. It could be a few microliters. Okay, 10 microliter or 5 microliter. That is the amount. And the concentration wise, if you want to know, then maybe 10 milligram per ml of the sample, or 1 milligram per ml of the sample. So again, that depends upon some experience, or by trial and error, you can put a particular amount of sample, you can apply the sample. And if it gives you proper separation, then you can keep that concentration. Otherwise, you can vary the concentration, so that the idea is that the sample spots must be very clear. Okay, the separation must be very clear. Okay, if the sample is too concentrated, then the separation will not be very good. There will be overlapping of the spots, or too big a spot will be there. And then it will be difficult to find out the RF value of that spot. Isn't it? In the usual case, people prepare 1% of the sample, that is weight by volume. Okay, 1% sample, that is milligram, 1 milligram per 100 ml of that sample, that is called 1% sample, right? And then like in the paper chromatography, here also the spot is applied towards one edge of the plate. Okay, either you can put a drop, okay, small drop, and immediately you can dry it with the help of a hair dryer, or there is something called as an automatic applicator. So especially when you are using HPTLC, that is high performance TLC, there you have automatic applicators where the known amount of the sample, or fixed amount of a sample, can be applied automatically by that sample applicator. Okay. And then for the development, okay, what is the meaning of development? That is when you keep your paper or your plate, TLC plate, in a developing chamber. That chamber contains a solvent system or mixture of solvents. Okay, and then you have to ensure that before you keep the plate in that chamber, or before you keep the paper in the chamber, that chamber must be completely saturated with the solvent vapors. Okay, because if the paper, if that chamber is not saturated properly, then the running of the solvent probably will not be even. Okay, it will not be uniform. Okay, and if the running of the solvent is not uniform, then there is a probability that the separation also will not be good, and the visibility of the sample spot will not be very good. Okay, the running of the spot will not be in one particular direction, right? And therefore, you have to close the lid of the chamber for some time, so that the entire chamber gets saturated with the vapors of the solvent, right? And only after that you can open up the lid, quickly keep your paper or your TLC plate in that chamber, and then close the lid once again, right? Now, when you are placing the plate, you should always ensure that the sample spot does not get dipped in the solvent system. Because if the spot itself dips in the solvent system, then what will happen? The sample will get dissolved in the solvent. Okay, so that should not happen. The level of the solvent system must be below the level of the spot. Is that clear? Yes or no?
Yes, sir.
Okay. So then you allow that mobile phase to rise up the stationary phase, that is by capillary action. Okay. And then along with the mobile phase, the sample spot also will be carried. And then, as I told you, at every point in that movement, there is an interaction which is taking place between the sample components and the stationary and mobile phase. Okay. And that is an equilibrated reaction. And therefore, some amount of the sample will be carried by the mobile phase. Some amount of the sample will remain on the, will be retarded on the stationary phase. Okay, so when that happens again and again, that results in the sample spot moving up the stationary phase. The different components, because they have different partitioning in the stationary and mobile phase, they will be carried over the stationary phase to a different extent. And that is the reason why the different sample components will get separated from each other. Is that out? Is that right? Then when the solvent front reaches towards the upper end of the plate, that is the time when you remove the plate. Okay, so that no further movement is allowed. And then because the solvent is a volatile solvent, immediately it will dry up. The plate will immediately dry up. And therefore, the moment you remove the plate, you can etch the surface of that plate with a marker. Okay, marker that is a pencil or something. Okay, so that you can make a marking on the plate to know where the solvent front has reached. Okay, हे कळतंय का तुम्हाला मी काय म्हणतोय ते? You have to scrape out the powder slightly so that you can mark the level of the solvent front. Is that clear to you? त्याला आपण etching out पण म्हणतो. Etching out. कोणाला नाही समजत आहे त्यांनी मला लगेच विचारा. कोणीच बोलत नाहीये, काय झालं? Are you all tired? आकाश?
No, sir.
No, sir.
नो कशाला बोलला? समजलंय ह्याला नो म्हटलास की टायर्ड आहे ह्याला नो म्हटलास?
We are not tired, sir.
Okay, okay. But have you understood, Akash?
Yes, yes, sir. Yes.
Okay.
Yes.
हे बघा, स्कीमॅटिक रिप्रेझेंटेशन वरनं तुम्हाला लक्षात येईल हे इथे सॅम्पल चेंबर आहे आपला TLC चेंबर, त्याच्यामध्ये सॉल्व्हंट सिस्टीम घेतलेली आहे, त्याच्यामध्ये ही प्लेट टाकलेली आहे. There is a spot on the plate here. Okay. And then of course assume that this chamber is all saturated with the solvent vapors, and then the stationary the mobile phase will run over the stationary phase. It will carry the sample spot. The different components in the sample will get separated, like X and Y, which are shown here. Okay. Okay, X म्हणजे त्यांनी solvent front दाखवलाय आणि Y म्हणजे actual sample दाखवलेले आहे. Okay. And then you can calculate the RF value. The typical RF value is in the range of 0.3 to 0.7. Okay. याच्यापेक्षा जास्त RF व्हॅल्यू येणं म्हणजे 0.7 पेक्षा जास्त RF व्हॅल्यू असणं म्हणजे काय झालं? Your sample is moving almost with the solvent front. That is to say, it is not getting retarded by the stationary phase. आपल्याला तसं नकोय. अजिबात रिटेन्शन व्हायला नको असं पण नकोय आणि खूप रिटेन्शन झालं असं पण नकोय आपल्याला. वी वॉन्ट समथिंग इन बिटवीन सो दॅट द सॅम्पल विल मूव्ह from the point of application, okay, to the solvent front, but not exactly to the level of the solvent front. Is that clear? जे सिलिका स्ट्रक्चर दाखवलेले आहे त्यांनी, ओके, हे जे सगळे ओ ओ ग्रुप्स दाखवले ना, हे these are the places where you can say hydroxylation can take place, okay, hydration can take place, okay, and therefore this silica also becomes, you can say, polar, okay. त्याच्यानंतर हे सगळं मी तुम्हाला ऑलरेडी सांगितलेलं आहे, त्याच्यामुळे आय विल जस्ट ट्राय टू मूव्ह अहेड. हे सगळं आपलं बोलून झालेलं आहे. सेपरेशन ऑफ लिपिड्स हे एक एक्झाम्पल म्हणून दिलेलं आहे. ओके, डिटेक्शन ऑफ लिपिड्स कॅन बी डन युझिंग प्लेनार क्रोमॅटोग्राफी, दॅट इज TLC. ओके, स्मॉल ऑर्गॅनिक मॉलिक्युल्स, non-polar molecules from the plant leaves, seeds, animal tissues, bacteria, cell membrane, हे सगळे वेगळ्या वेगळ्या प्रकारचे सॅम्पल आपण सेपरेट करू शकतो using solvents. Okay, and these solvents are, for example, ether, acetone, hexane, then a mixture of chloroform and methanol in the proportion of 2:1, hexane isopropanol in the proportion of 3:2. असे वेगळे वेगळे कॉम्बिनेशन आपण घेतो. मग हा प्रश्न तुम्हाला येईल का असं मनामध्ये, की हे प्रोपोर्शन का दिले असं 3:2 किंवा 2:1? हु डिसाइड दॅट प्रोपोर्शन? कशावरून ठरवलं ते की क्लोरोफॉर्म आणि मिथेनॉल 2:1 घ्यायचं? ब्युटॅनॉल, ऍसिटिक ऍसिड, वॉटर हे एका ठराविक प्रपोर्शन मध्ये घ्यायचं. आपण बघतो असं जर्नलमध्ये असं लिहिलेलं असतं. वेन यू आर ट्राइंग टू राईट द जर्नल यू विल अंडरस्टँड दॅट. तर प्रश्न असा आहे की हे रेशो कोण ठरवतं? कॅन यू आन्सर दॅट क्वेश्चन? सगळे गप्प का बरं बसले? आज ती मुलगी नाहीये बोलणारी, तिचं काय नाव आहे? हजारी. हजारी, तिचं काय नाव आहे पहिलं?
तेजस.
हा, तेजस. तुला बरोबर लक्षात आहे. बर, तर कोण सांगू शकेल हे उत्तर? हाऊ डू वी डिसाइड द प्रपोर्शन ऑफ द सॉल्वंट्स विच आर यूज्ड इन द सॉल्वंट सिस्टम? भीमभूषण, तूच बोलतोयस का?
हो सर.
हा, का ऋषिकेश बोलला? मग मला काही कळलं नाही कोण बोलला.
सर प्रपोर्शन.
हा,
काय
काय काय म्हणतोयस भीमभूषण?
सर सर सांगता नाही ना कोण ठरवतो?
कोणाला सांगता येईल हे? ऐश्वर्या, कॅन यू टेल?
नो आयडिया.
अरे मग तुम्ही काही ऐकत नाही माझं राव. मी सगळं तुम्हाला सांगितलेलं आहे ना, ह्या गोष्टी तुम्हाला सांगितलेलं आहे म्हणून मी विचारतोय तुम्हाला.
पोलॅरिटी.
येस, कोण म्हटलं?
ऐश्वर्या सर.
ऐश्वर्या, काय सरनेम आहे तुझा? कुलकर्णी. कुलकर्णी, राईट. हा, या व्हॉट ऐश्वर्या इज सेइंग इज एब्सोल्युटली करेक्ट. इट इज ऑन द बेसिस ऑफ पोलॅरिटी. मी तुम्हाला सांगितलं ना की पोलॅरिटी आपण ऍडजस्ट करत असतो. ओके, सो 3:2, 3:4, 3:5 जे काही प्रपोर्शन इथे लिहिलेलं आहे दॅट इज बेस्ड अपॉन द ऍडजस्टमेंट ऑफ पोलॅरिटी. आणि पोलॅरिटी आपण ऍडजस्ट का करत असतो? तर वेगळे वेगळे कंपोनंट्स आपल्या मिक्सचरमध्ये आहेत, ते एकमेकांपासून सेपरेट व्हायला पाहिजे. द कंपोनंट शुड इंटरॅक्ट विथ द मोबाईल फेज अँड द स्टेशनरी फेज. हो की नाही? ते इंटरॅक्शन होण्यासाठी आणि तो स्पॉट पुढे मूव्ह पण झाला पाहिजे, त्यातले सॅम्पल कंपोनंट सेपरेट पण झाले पाहिजे एकमेकांपासून. Isn't it? For that we have to adjust the polarity of the solvent system. कळतंय का सगळ्यांना? दिवेकर?
येस सर.
ओके, कळालं असेल तरच म्हणा येस सर.
हो सर.
ओके, त्याच्यानंतर हे मी स्किप करतो आहे. तुम्हाला हवं तर तुम्ही याचा स्क्रीनशॉट घेऊ शकता. ओके, आणि पुढे जाऊयात आपण. हे सगळं प्रॅक्टिकलला ऍक्च्युली आहे. तुम्ही जर इथे जॉईन केलं इन्स्टिट्यूटला तर मग हे प्रॅक्टिकल आपल्याला करता येईल. नाही तर मग ऑनलाईनच मला तुम्हाला सगळं सांगावं लागेल प्रॅक्टिकल कसं करतात ते. ओके, so for the practical discussion I will during the discussion I will tell you all these slides. Okay, then coming to the detection methods, we have different methods for detection of the sample spots. One is called as the fluorescence method, where fluorescent conjugated molecules are seen under the UV light. What is conjugated molecules? म्हणजे एक डाय असतो, त्या डाय मध्ये फ्लुरोसन्सची प्रॉपर्टी असते. So if that dye is already bound to the sample components, then the sample components will be seen as fluorescence. Okay, fluorescent spot दिसतील आपल्याला त्या प्लेटवर, राईट. पण हे आपल्याला UV च्या खाली बघावं लागेल, then you can see the spots. Otherwise what we can do is we can put a zinc salt in the silica gel. जेव्हा आपण ते प्लेट बनवत असतो ना, when we are layering that plate, okay, or when we are coating that stationary phase material on the support material, during that time we are adding a zinc salt. Okay, and because of that what happens is the sample spots, especially the organic samples आपण जे बघतो किंवा biological sample materials असतात आपले, so these spots will appear dark in color. Okay, and the background will appear fluorescent blue green in color. Okay, that is under UV light. तिसरा जो प्रकार आहे, we can use a radioactive material to label the sample components. Okay, and then by using certain methods like autoradiography, जे आपण नंतर बघणार आहे इलेक्ट्रोफोरेसिस मध्ये. Okay, so by using autoradiography we can see the sample spots on the plate. Okay, किंवा एक साधी गोष्ट सांगायची म्हणजे एक फोटोग्राफिक फिल्म असते किंवा एक्सरे फिल्म असते, ती फिल्म जर आपण याच्यावरती ठेवली आपल्या प्लेटवरती, TLC प्लेटवर, तर काय होतं, रेडिओ ऍक्टिव्ह मटेरियल जिथे आहे आपलं, कारण आपण बाइंडिंग केलंय ना, रेडिओ लेबल केलेलं आपल्या सॅम्पलला. ओके, सो बिकॉज ऑफ दॅट रेडिओ ऍक्टिव्हिटी that particular place, that particular point in that X-ray film or photographic film will get exposed. Okay, म्हणजे फिल्म वरती आपल्याला ते स्पॉट दिसतील, राईट. Or we can use something called as a universal reagent. Universal reagent म्हणजे काय, something which will develop all organic molecules. म्हणजे त्याच्यामध्ये काय असं पर्टिक्युलर स्पेसिफिसिटी नाहीये. All organic molecules, for example all proteins or all sugar molecules, they will give a particular color. For example आपण जर H2SO4 स्प्रे केला, concentrated H2SO4 sulfuric acid, if we spray it on the plate, then all the organic molecules will appear black in color. Okay, black spot दिसतील आपल्याला. ओके, त्याच्यानंतर आपण ऑलरेडी बघितलं की अमिनो ऍसिड जर आपल्याला पाहिजे असतील TLC प्लेटवर, तर देन वी कॅन यूज अ रिएजंट कॉल्ड निनहायड्रीन. ओके, सो ऑल द अमिनो ऍसिड विल बी स्टेन्ड. ओके, पिंक कलर, पिंक और व्हायलेट असा कलर आपल्याला दिसतो प्लेटवरती. देर आर सम एक्सेप्शन्स. प्रोलीन फॉर एक्झाम्पल विल अपियर येलो इन कलर. ओके, प्रोलीन जर आपण वगळला तर बाकीचे सगळे अमिनो ऍसिड जे आहे ते आपल्याला पिंक कलरचे दिसतात. पिंक टू व्हायलेट कलर स्पॉट्स आर सीन ऑन द प्लेट. ओके, असे हे वेगळे वेगळे एक्झाम्पल्स इथे मी दिलेले डिटेक्शन साठी. अँड देन मेजरमेंट ऑफ कोर्स इज बेस्ड अपॉन द रिटेन्शन फॅक्टर. वी हॅव ऑलरेडी सीन द फॉर्म्युला फॉर रिटेन्शन फॅक्टर. ओके, सो आय विल गो अहेड. आणि मग इथे एक रेझोल्युशन नावाची कन्सेप्ट मांडलेली आहे की कशाला चांगलं बनायचं सेपरेशन. आता तुम्ही जर ह्या डायग्राम मध्ये बघितलं तर ह्या, कॅन यू सी माय स्लाइड हिअर, स्कीमॅटिक डायग्राम दाखवली आहे, ते दिसतंय का तुम्हाला? येस ऑर नो? कोणी बोलत नाहीये. शुभांगी आहे का? कॅन यू हिअर मी शुभांगी? सगळे आले का? कॅन यू ऑल हिअर मी? या मीटिंगला एक 2-3 मिनिटं
Yes,
राहिले
sir.
असतील, 2-3च मिनिटं राहिलेले असतील. ओके, सो वी आर गोइंग टू जॉईन अगेन. ओके, पुढे एक परत 10-15 मिनिटं मी लेक्चर घेणार आहे. इज दॅट क्लिअर? ओके, तर ही स्लाइड तुम्हाला दिसतेय का माझी? कॅन यू ऑल सी दॅट? अरे भीमभूषण, कॅन यू हिअर मी? भीमभूषण,
येस सर.
कॅन यू टेक द अटेंडन्स प्लीज?
शुअर सर.
ओके प्लीज, हा, कारण हे बंद होतीये मीटिंग, तर पटकन तू हे करून टाक स्क्रीनशॉट. ओके, सो आय वॉज टेलिंग यू अबाउट द रेझोल्युशन. तुम्ही जर इथे डायग्राम मध्ये बघितला तर इथे भीमभूषण तुझा माईक बंद कर. ओके, कॅन यू सी द टू स्पॉट्स हिअर विच आर अवे फ्रॉम इच अदर स्लाइटली? त्यांच्यामध्ये काहीतरी डिस्टन्स आहे. आणि दुसऱ्या पॅनेलमध्ये जर तुम्ही बघितलं तर हिअर द टू स्पॉट्स आर ऑलमोस्ट लाईक दे आर ओव्हरलॅपिंग. दिसतंय ना?
Yes, sir.
तर तुम्ही जर एक असं इमॅजिन करा, एक छोटंसं कॅल्क्युलेशन करायचं आपल्याला, की डिस्टन्स बिटवीन द सेंटर ऑफ द स्पॉट, म्हणजे ह्या स्पॉटचा सेंटर जर आपण घेतला ह्याचा आणि ह्याचा, आणि ते डिस्टन्स जर आपण मोजलं, ओके, अँड इफ आय डिवाइड दॅट डिस्टन्स बाय द ॲव्हरेज डायमीटर ऑफ द स्पॉट, म्हणजे दोन्ही स्पॉटचे डायमीटर टोटल करायची आणि मग त्याला डिवाइड बाय 2 करायचं, मग ती जी संख्या येईल त्याच्याने आपण डिवाइड करायचं कशाला? डिस्टन्स बिटवीन द सेंटर ऑफ द स्पॉट्स. सो इफ द टू सिच्युएशन्स आर हिअर, तुमच्या असं लक्षात येईल कदाचित की ह्याच्यामध्ये जर ते आपण कॅल्क्युलेशन केलं तर ती जी व्हॅल्यू आहे ती 1 पेक्षा जास्त येणार आहे इथे, आणि इकडची जी व्हॅल्यू आहे ती 1 पेक्षा कमी येणार आहे. कॅन यू अंडरस्टँड व्हॉट आय एम सेइंग? कळतंय का सगळ्यांना? आकाश,
Yes, sir.
आरती, आरती, कॅन यू हिअर मी?
Yes, sir.
हा, हे कळतंय का मी काय सांगतोय कॅल्क्युलेशन? येस ऑर नो? आरती, आरती, कॅन यू हिअर मी? दिव्या
Yes,
अग्रवाल,
sir.
दिव्या,
Yes, sir.
वैष्णवी, अजून कोण कोण आहे? पाठक, याज्ञासिनी,
Yes, sir.
ऋषिकेश,
Yes, sir.
अजून कोण आहे? शुभांगी, सायदा, कॅन यू अंडरस्टँड?
Yes, sir.
ओके,
Yes,
शुभांगी,
sir.
हा, वैदेही. दोघींचा आवाज सेमच आला मला, शुभांगी आणि सायदा. शुभांगी,
No, sir. I answered after her. I answered
Yes,
after Shubhangi.
हो ना, पण दोघींचा आवाज मला एकदम सेम आला. दॅट इज गुड, सरप्राइझिंग थोडं. वैदेही, विशाखा, डिड यू अंडरस्टँड?
Yes, sir.
हे जे कॅल्क्युलेशन मी
Sir.
तुम्हाला म्हणजे इमॅजिनरी कॅल्क्युलेशन सांगितलं, ते कळलं नसेल तुम्हाला तर मग मी तुम्हाला ऍक्च्युअल व्हॅल्यूज घेऊन सांगेन. पण तुम्हाला कळलं असेल तर मग ठीक आहे, देन आय विल गो अहेड. ओके, फक्त सांगायचा इथे मुद्दा काय माझा, की इथे इफ यू टेक द डिस्टन्स बिटवीन द सेंटर ऑफ द स्पॉट्स अँड डिवाइड इट बाय द ॲव्हरेज डायमीटर, then that value will be greater than 1, and here that value will be less than 1. Okay, then as per the definition of the resolution, that distance must that particular ratio must be greater than 1. जर greater than 1 असेल तर याचा अर्थ असा होतो की the two spots are getting well separated from each other. प्रॉपर सेपरेशन त्या स्पॉट्स मध्ये होतंय. ओके, आणि ते जर तो जो रेशो आहे तो जर लेस दॅन 1 असेल तर याचा अर्थ सेपरेशन झालेलं नाहीये प्रॉपरली. ओके, थोडंसं हे कॉमन सेन्सचं म्हटलं तरी चालेल. तुम्हाला डायग्राम बघून पण लक्षात येईल की पहिल्या केसमध्ये सेपरेशन चांगलं झालेलं आहे, दुसऱ्या पॅनेलमध्ये जे दाखवले त्याच्यामध्ये सेपरेशन कमी झालेलं आहे. ओके, and then if your interest is in the purified compound, then of course your resolution should be more than 1. ओके, RS म्हणजे रेझोल्युशन. इज दॅट क्लिअर?
Yes, sir.
आता इथे ह्या स्लाइड मध्ये त्यांनी काय केलंय, वेगळे वेगळे स्टेशनरी फेजेसचे नावं दिलेले आहेत. मी काही हे सगळं वाचत नाही बसणार आहे. तुम्ही जर याचा स्क्रीनशॉट घेतला तरी चालेल.
Sir, slide visible nahi hai.
ओके, आय विल शेअर इट अगेन. आणि ही मीटिंग आता बंद होणार आहे. तर बंद झाली की आपण पुन्हा एकदा जॉईन करूया. ओके. Can you see it now?
Yes, sir.
Okay. So that is a list of different types of stationary materials which are used in TLC. ओके. ह्याच्या पुढे जाऊया आपण. हे सगळं वाचण्यामध्ये काही मला एवढं महत्वाचं वाटत नाहीये. ओके. आणि मग मी तुम्हाला केव्हा तरी बोललो होतो की रेडीमेड प्लेट्स पण अवेलेबल असतात. सो दिस इज अन एक्झाम्पल. दिस इज अ ऍक्च्युअल फोटोग्राफ ऑफ TLC प्लेट्स विच आर अवेलेबल इन द मार्केट. तुम्हाला दुकानामध्ये जाऊन हे मिळू शकतं. ओके. कुठल्या दुकानात मिळेल हे ऋषिकेश?